such a privilege to speak to you guys tonight in the coveted last time slot of DevCon. That's right, I am what is between you and beer. But with that said, I do have a concern. Being the last DevCon talk of 2014, I'm sure many of you guys are worn out from hearing amazing talk after amazing talk. And there we go. So I'm afraid that most of you be like this, checking Facebook, surfing Reddit, and so on. So in an effort to get everyone to pay attention this late in the day, I took all the technical theory and philosophy from my talk and replaced it with internet memes and cute animal pictures. Since there's no need to pay attention to your phones now, since you can catch all your favorite memes right here. So with that, let me introduce myself. I am Jason William Thompson. I am a senior software engineer on the CAM Platform Services team, and I've been with Cerner since May of 2011. Today, I want to talk to you guys about a library called Hamcrest. Hamcrest allows developers to refactor their tests into legible and maintainable components. Speaking of refactoring, I was chatting with some engineers earlier at DevCon. They noticed my super awesome red speaker badge and wanted to know what I was going to be presenting. I told them that it was about refactoring unit tests by developing Hamcrest matchers. I'm guessing they were newer engineers because one of them gave me a puzzled look. One of them asked, well, isn't refactoring a waste of time? Why change working code? On the contrary, I replied, refactoring pays for itself in the amount of time you save maintaining the code. So we talked a bit more, and eventually one of the engineers piped up and asked, well, that's great, JT, but how do I know when to refactor my code? That's a great question, I told them. Just come to my talk later on today, and I will give you a list of 5 examples of when to refactor your code. So with that, here is my list. Number 5, you should probably refactor your code if your source has less documentation than a piece of IKEA furniture. Number 4, you should probably consider refactoring if your solution has more duplicate logic than a sheep cloning farm. Number 3, you should consider refactoring if your code is more cryptic than the Matrix. Number 2, you should consider refactoring if your associate ID is more descriptive than the identifiers in your source. And finally, number 1, you should consider refactoring your code if your inheritance hierarchy is more confusing than this guy's. And for those of you who are not familiar with internet memes, this is almost politically correct redneck. We laugh at these things because we recognize the pain and suffering that these bad practices cause while having to support and maintain our solutions. We know that they are bad, but oddly, while seasoned programmers will avoid such code smells in our implementation, we seem to be a bit more apathetic when we commit such violations in our test code, such as our white box tests and our black box tests. But I'd like to argue that we need to treat unit tests with the same or a similar level of care as our implementation. To illustrate why, let me tell you guys a brief story. One day I was assigned a class that caused me to miss our iteration start meeting. And I love taking classes here at Cerner. They're kind of like going to DevCon and you learn a lot of great things. But I asked my team to pick out some good stories for me to work on the next iteration since I had all my stories done. Perhaps their idea of what a good story was differed from mine, because when I got back from the class, I was assigned the largest story on the backlog. It wasn't a terribly complex story, but there was a lot of manual work involved. I needed to take a core interface that is used throughout the entire solution that we're building and break it into 3 distinct interfaces. Like a lot of seasoned developers, I tried to avoid busy work. So I figured I'd use Eclipse's built-in refactoring tools and some regular expressions to knock out 90% of the project. And this worked great for our implementation because it is well written and maintainable. Our tests were a different story. Sure, our tests accurately verified that the code was doing what it was supposed to be doing. Sure, our tests had a high code coverage. But the way the tests were written made it difficult to refactor. Specifically, it contained little documentation in places, some questionably named identifiers, and a bit of duplicate logic. Recognizing these things, I amended my assignment a bit. I decided that I would not only get this interface broken out into 3 distinct interfaces, but that I would also improve upon the unit tests so that I would only have to suffer this pain once. Obviously, I couldn't fix everything, so I focused on fixing one thing, reducing the number of duplicate assertion methods. And since I was going to be consolidating these methods anyway, I decided to replace these assertion methods with Hamcrest matchers. So why did I choose Hamcrest? One of my favorite heroes in engineering is Shigeru Miyamoto. He is a gentleman who created works such as Mario, Zelda, and so on for the Nintendo brand. And Shigeru Miyamoto once says, "A good idea is something that does not solve just a single problem, but rather solves multiple problems at once." And Hamcrest indeed solves several problems that I identified a few moments ago. To understand what Hamcrest solves, let's dive into what Hamcrest even does. Hamcrest is a library of matchers that match objects against a condition, such as whether 2 objects are equivalent, or if an object exhibits some property. Hamcrest also contains an API that allows developers to write their own custom matchers for their own specific needs. Here's an example of a JUnit test using Hamcrest. Can anyone tell me what I'm asserting? Just shout it out. Okay. Yes, exactly, Saul. This asserts that some process string contains a length that is now even. It will either assert that that is true or fail the condition. Now, you may be wondering why anybody would do this rather than using a simple assert true. After all, I could have written the last line like so. I would concede that for very simple assertions, it may be easier just to use the built-in JUnit methods such as assert equals and assert true. The more complex the assertion, the more valuable Hamcrest becomes, since matchers allow us to reuse complex assertions. In this talk, I'm using a simple example so that the concepts can be understood without having to understand unrelated complexity, and so that the examples fit on the screen. But as you will soon find out, even for simple assertions, Hamcrest is beneficial for 3 reasons. First, Hamcrest provides syntactical sugar that makes our tests expressive and easy to read. Second, Hamcrest allows developers to combine multiple matchers together to create more complex matchers. And finally, it provides a clear explanation when a matching attempt fails. For those who don't know, this has nothing to do with Hamcrest, but this is an actual error message from the new Microsoft Xbox One, and I saw this out earlier today. Clearly, it doesn't provide a clear explanation for what went wrong. And if you can't read that, it says, "Something went terribly wrong. Please come back later." So let's go through some examples. Like I said, the first benefit of using Hamcrest matchers is that Hamcrest is more expressive. Even if you have never used Hamcrest, it was immediately obvious what I was trying to do. I wanted to verify that the length of a string was even. With assert true, one would have to read and understand the logic to understand what's going on. And again, the second benefit of using Hamcrest is that you can assemble matchers together. You can combine different matchers to make a more complex matcher. What if I wanted to know if a collection of numbers were all even? I could just add an every item matcher. What if I wanted to see that they were all not even, or that they were all not even, rather? I can throw a not matcher in there. What if I wanted to see if there was at least one odd number in my collection? That is to say that not every item is even. I can move my not matcher to the outside. Notice that even when I move my matchers around, the code is still obvious as to what's going on. It truly is self-documenting. Now, the third advantage I discussed of Hamcrest is what really sold me on using it for writing assertions. When a test fails, the description of the failure tells me exactly what went wrong. Let's run through our examples again with the bad test data. First, we'll run the examples without Hamcrest. Here we have a test that had failed, but we have no idea why. As a disclaimer, we would normally get a stack trace, but for the sake of this presentation, I've chosen not to show the stack traces so that you can see the messages that the test will return. For a simple example like this, it's trivial to determine the cause. But what if we were asserting something more complex, like a person object? Wouldn't it be nice to learn that the person didn't match the expected because the logic that assembles the person flipped the first and last name? With Hamcrest, you can do that. Now, let's run the Hamcrest version of this test. We can clearly see that what we are expecting is an even number, but got an odd one. Well, what about our other tests where we combine matchers? Here we can see that expected every item to be even, but an item is odd. Here we can see that it expected every item to not be even, but there was an odd one, there was an even one. And you'll notice that sometimes when you combine matchers, you'll lose some of the error messages, but it's still very easy to see which item in our collection caused the problem. Here we can see that expected some of the numbers to not be even, but they all were. The failure messages build themselves. Now, in case you're not pumped about using Hamcrest yet, let me show you a few of the other matchers. Contains in any order can match that all items in a collection exist in an order-agnostic fashion. If the order matters, you can use contains. Want to see if a collection has at least one item that matches a matcher? Use has items, or has item. Want to see if a collection has several items? Use has items. All right, now that we see what Hamcrest can do, let's learn how to make our own matchers. There are several types of matchers, but I typically only use one. And it's called the type-safe diagnosing matcher. A type-safe diagnosing matcher does exactly what it says. It matches a specific type of object, and it will diagnose failures. Now, just to make things interesting, the matcher we're going to make will be a little more complicated than the even matcher that we were using earlier. I did promise cute animal pictures, so here's a really cute puppy I found on the internet. But with that, let's pretend we're writing a veterinary solution that helps vets care for pets. In this solution, we have a dog interface. We want to create a dog matcher to be used in various tests to verify that the dog we get back is the one we expect. So, the first thing we do is we create a class that extends type-safe diagnosing matcher of dog. Now, let's add some stubs for the abstract methods describe to and matches safely. We'll come back and we'll implement those later. Since we're going to compare two dog interfaces, we need to take in an expected dog. In order to do that, we'll implement a private constructor that takes in a dog, and a public factory method named matches dog that will return us an instance of this matcher. So why do we do this? Why not just allow consumers to new off a dog matcher? Well, we could, but there are 3 reasons for this. First, the factory method provides syntactical sugar so that your test can be easily understood. Imagine writing a test and saying, assert that some dog, comma, new dog matcher, expected dog. That doesn't make as much sense as assert that some dog matches dog, expected dog. The second reason why we want to use factory methods is because it can be annotated with the factory annotation. This can then be read by utility provided by Hamcrest that allows us to consolidate all of our matchers of a particular group of libraries into a single class called matcher that will have all of those stacked methods in there. And then finally, the third reason why you want to use factories instead of newing off your matchers is because you can return a different matcher than the matcher you're writing. I'll implement matches dog to show you what I mean. Here, if we get null for the expected dog, we'll just return null matcher instead of dog matcher. Now that we have our expected dog, let's implement describe2. Describe2 describes the expected condition. Examples might include something like even or prime. In our case, we're going to return a dog object that matches our dog. To figure out what we should return here, just simply say to yourself, my matcher should verify that an object is blank. Whatever you would put in that blank is your describe2. Finally, let's implement matches safely. Here, I create a matcher that identifies that each one of the dog's properties are set. And this one's interesting, and so I'm going to explain it a bit more. The first line, we can see that we are getting a matcher back from Olive. Olive is a static method that returns an Olive matcher. And then there's a matcher called hasProperty. HasProperty will do some reflection to figure out if your object has a particular property. So in our dog interface, we have a method called getBreed, as well as getColor, getName, and getUID. Then hasProperty can take in a second matcher that tells us how to validate if that property is correct. In this case, we're using the is matcher, which is essentially saying that we want to make sure that they are equivalent. So we take our expected dog, and if you remember, that is a field in our class, our matcher class, and we compare the properties of the dog that was passed in with getBreed, getColor, getName, and getUID of the expected. And so you can see that if the matcher fails when we call matches, then we need to write out an error message. For this example, I am using the built-in error message of the Olive matcher. And so I'm calling matcher.describe mismatch to the mismatch description, and then I'm going to return false. Now, what's interesting is when your assertions fail, it will call your matcher twice. The first time to see if the matcher or the assertion failed, and then the second time to write out the error message. But if everything else turned out correctly, then we're just going to simply return true. And that's it. That's all it takes to write a Hamcrest matcher. And I just couldn't help myself. I had to put this in here because in order to implement my matcher, I used a more complex matcher. Something else that's interesting is if you were paying attention earlier when I said that your factory can return any matcher you want, I could have just returned this olive matcher from that factory method instead of implementing all this. But normally, in your matches safely method, you'll want to add some specialized logic to help customize your matcher, or you might want to have a specialized error message so that you can alert the tester exactly what went wrong when the assertion fails. And so we went over several things, and I don't expect any of you guys to be Hamcrest experts coming out of this, but I hope that I've left you guys with a couple things. First, I hope I've shown you enough about Hamcrest so that you would go out and explore it. Second, and more importantly, I hope that I've given you guys the desire to want to go out, look at your solutions, and think about what can I do to make this better. The code is great, but how can I make it greater? And so with that, I would like to open it up for questions. And if you guys don't have any questions, I've got a few more slides that we can talk about. Sure, go ahead. And please talk on the microphone so I can hear you.
Okay, so I'm kind of intrigued by Hamcrest library. It sounds really interesting.
Yep.
I want to know what the licensing is for it if I want to use it for my Sooner project.
Oh, that's a great question. Do you use JUnit by any chance?
Yes.
How about Mockito?
Yes.
Hamcrest is actually a dependency of both of those things. So JUnit decided to use Hamcrest in their JUnit 4 implementation because it does provide a lot of those benefits I talked about during this discussion, specifically being able to do a type-safe match. Because if you recall, in JUnit, you have an assertion method called assert equals. Well, all that does is that calls dot equals on your various objects, right, that you pass into it. And so to make a more complex assertion, you would have to call assert equals several times, once for each property. And you can't really use that other than perhaps bundling it up into a method. Mockito also uses Hamcrest or has some hooks that allow you to use Hamcrest matchers for a lot of the same reasons. So if you recall with Mockito, oftentimes you want to verify if a mock method was called. Well, you can not only verify that a mock method was called, but you can verify that some property of that method is true. Perhaps you want to see if the mock service was passed an even number or some other condition. You can do that with Mockito using Hamcrest. Can't remember what it is off the top of my head. There's another popular unit testing framework for Java, and that also uses Hamcrest. And so you already have it. So there you go. That was an excellent question. Are there any other questions? Okay, well let me jump into something interesting. A fake Twitter tweet. So some of you might not program in Java, and you might be wondering, well, this is really neat, and I wish it was available in my language. Well, the good news is there are Hamcrest implementations in different languages, such as Python. And you'll notice that the different implementations will use the same kind of syntax and stylized rules as their base language. With Python, you'll notice that the is matcher has an underscore because, as we know, is a keyword in Python. And so in different languages where those conflicts occur, you'll see that they make interesting substitutions. So in Ruby, this one's interesting because not is a keyword in Ruby, right? And so instead of using not, they just say ain't. Works for me. Objective-C actually looks the closest to Java. And so a lot of the same kinds of matchers that you find in the Java implementation, you'll find in the Objective-C. I haven't really found anything in that implementation that's very much different. And I know there are some Perl people out here who are dying to wonder, well, is this in Perl too? No. And but I'm sure they've got something else. But no, it's not available in Perl. But it is available in several different languages that I haven't listed. And so I would encourage you guys to go out to Google and Google Hamcrest, and then right on their site, they'll have links to every one of the implementations. And so with that, has anybody thought of any other questions that they are interested in learning more about regarding this library? Well, I left enough out that I thought that there will be some questions. But if not, I guess we can end this early. This is a link to my USERN blog. And on my USERN blog, I talk a lot about testing because for some reason it's been an obsession of mine lately. How to write tests better, how to mock things better, and whatnot. And before you go, just like all the other talks, if you want to give me an upvote, if you're a Redditor, you know what I mean, do a +1. If you're like, meh, this is all right, 0. And if you just totally didn't like it, give me a -1. But I would ask for some feedback. This is my first time doing a presentation like this, and so I'm interested in seeing what I can do better for next time or what you guys really liked. Thank you very much for being here today, and thank you for such a great DevCon, and have a great rest of the week. Thank you.